Hey everyone, bet you didn't expect to see a video so soon. In this video, we're going to learn how to create a dApp for PDAs. So for a quick recap, my name is Josh, and this channel's mission is to accelerate the world's transition to blockchain technology. And for a quick recap, this video will exclusively be about building the front end to work with the PDA that we developed in our previous video, where we learned how to create a smart contract that works with PDAs. What this dApp will be able to do is we will be able to connect to the user's Phantom wallet to make a transaction to our smart contract, and specifically how we work with PDAs. As always, this video is sponsored by myself. Check out the previous videos I made in my playlist to catch up on some of the knowledge that you might be missing. And of course, disclaimer, this is not development advice. You rug pull someone, you get sued, on you. All right, so a quick recap of everything that we've done up to this point. So, what are PDAs? PDAs are program derived addresses. Essentially, they are accounts that are owned and modified by your smart contract as a third party, and not by any individual, not by me, not by you, not by your uncle. And a quick reminder again, accounts are custom data that is stored on the Solana network. The one special thing about PDAs is unlike our wallet keys that we have, where we have a public and private key, PDAs don't have a private key. And so how are PDAs represented? We talked a bit more about this in the previous video, but you see the curved line over here. Any dot, which are think of public keys, any public keys on that fit on that line is a valid wallet. Essentially, it has a public private key. Any dot that's not on the line is not a public. It is a PDA. And so how are PDAs created? We have a concept of a seed, which are essentially just random variables that are used to generate a hash on the curve. So think of it like your hash map or your hash function that you've worked with in programming. And then of course we have a bump for in the case where our seed ends up on the line. And if it's on the line, we just use the bump value to move it out of the line. All right, so continuing on our recap, we made a escrow example in the previous video. We want to have a third party to hold the funds that we want to transfer to another individual. And the reason we use a PDA is because we want a decentralized third party to hold our money, which really in this case is just an integer. And the seed we use for that is we have a fixed string called escrow. We need to use the sender's public key and then the receiver's public key. And these three together will generate our PDA. So here's the code that we made. I'll just quick go over. This is the context for our anchor code. As you see, like we kind of discussed, there are four things we take in. There is our PDA that will hold the money. We have our from, the person who's sending it, the to, who the person who's receiving the amount, and then system program, which is required for our code to compile. And if we look at our PDA, it's represented by this escrow account, as you see right here. The PDA, the escrow account takes in three fields: the from, the to, and then amount. In theory, we write a smart contract that interacts with this account to set and eventually deliver the amount. Of course, in this video, we're not going to do that. We're just purely learning about how to interact with a PDA. So now, okay, not the slide. So now we're going to learn how to actually create our dApp. So it's a four-step process. First, we're going to use the wallet adapter, the Solana's wallet adapter, Next.js example to create a project to connect to Phantom Wallet. Then we're going to generate the IDL from our Anchor program that we've made in the previous video. Those will be important to be able to talk to our smart contract that we deploy. Then we're going to deploy our front end to actually talk to our program. And then finally, there's some small little setup work thing. All right, so first step, we're going to create our starter project. So I'll include the slide in the description. I'm actually not going to go through the process because, to be honest, no one wants to watch me do all of this. I'll actually have a repo for you to clone later, so you don't have to actually go through this process. But essentially, we want to go to Solana Labs wallet adapter GitHub repo, and this essentially is the GitHub repo that allows us to connect to the user's Phantom wallet. Really, any other Solana wallet, but Phantom was the most popular, or the one I've been using. Clone the repo, and then the starter project is located inside the wallet adapter package starter Next.js starter folder, and that's where we'll just be building up our code. But don't worry, I'll have our final project on a separate GitHub repo for us to clone it all through. All right, so now we need to create our Anchor IDL. So if this is actually your first time doing this, and maybe you ran into some problems in the previous video when you tried to deploy, but this is your first time, you need to do some setup work for your Solana. First, you need to create a key pair that will be used to actually pay for things like deploying your contract. And that's what A and B is. First, you make a folder to contain your key pair, and then you run Solana keygen new file, the folder, and then my key pair JSON. That's just a random file that'll store your key pair. All right, then you can get your public address by just executing this command. So this will give you your public key, which we'll be using for later. And some other setup work is we need to ensure that we are on localhost. There's multiple different environments on Solana that we can work with. There's localhost, testnet, devnet, and then mainnet. In our case, we're always going to work in local. So we run this command to set us in that right location. We can start our local validator nodes by running Solana test validator, very important. And then once we do that, we need to airdrop some SOL into our public key that we just recently generated. And that's just Solana airdrop 3 is the number of SOL we're sending. And then we just give the public key that we generated from step. And that should get you started. Now onto the actual work. So what is the Anchor IDL? The Anchor IDL essentially is just a JSON file that the Anchor library generates for you, and that it contains all the metadata that we need, including the addresses and the fields that our front end will use to communicate with our smart contract. So to create in our program, we just need to do an Anchor build. We need to start our Solana test validator because we are deploying on our localhost, and we execute Anchor deploy. And then and we'll go through this, but once you deploy, you'll see another address in the command line. We want to take that address and put it back in our smart contract because by default, when we generate a new Anchor project, it just has the same static address. And then one step I didn't include is, but we need to Anchor deploy again to make sure that our address is actually shown properly in our IDL file, and only then can we go find it at the /target /IDL/demo PDA JSON file. And then once we have that, we can just copy and paste and move it to our dApp. So let's just quickly go through that. Right. So make this bigger for us all to see. All right. So I'll open up our browser, our Explorer. So first thing is I'm going to make this. So you see, I already have an address, but let's just go through everything again. So first, we need to start our localhost, so that's Solana test validator. This will start our node, as you see, is right there, and we can just open a new terminal. Build. And if this isn't obvious, this was the project that we made in our previous video. I will link it in the description below. But if you saw this video, you can just clone this repo and follow along if you want. Anyways, so okay, Anchor build, and we want to Anchor deploy. Honestly, you might not even need to Anchor deploy or Anchor build first, but I've found that sometimes there are issues, so I always kind of. Okay, anyways, so now that we finished this, you can see that there's a program ID right here. If this is your first time doing this, you'll have some random ID. So you want to just replace this, paste it, and then do Anchor deploy again. And this will deploy your smart contract on a network with the correct address. And just as importantly, if you go to your target folder, IDL, demo PDA JSON, and you scroll to the very bottom, you'll know if it works if this metadata gets generated with your address. So that's all we need to do. So before we do that, let's quickly go back into our slide. Actually, you know what? Let's just do it. So over here is another project. It's the actual front end. I will include the link to the repo below. I'm not going to waste our time just typing it up. We're just going to go through the code. If you actually prefer if we type it up or I do my other thing where I copy and paste, do let me know in the comments. but I think this is probably the fastest way for me to just transfer knowledge. So um, for those who aren't aware what Next.js is, don't worry, I'll make another video actually just to kind of talk about the basics of it. So just follow along the code. How Next.js works isn't too complex once you understand some of the basics. But if you aren't familiar with React or TypeScript, then yeah, this might be a bit tough to follow along. Sorry, but that's just how it is. Anyways, so we are opened up on the root directory of our project. And this was directly taken from the starter project from the wall adapter. And what I did was inside the public folder, I made a new file called idl.json. And what I did over here is, see right here, we have the IDL from our smart contract. So all we need to do, we didn't do it before, was copy and paste the JSON file from our smart contract, and then paste it over here in our front end code, and save. And we'll use this later to be able to talk to our smart contract. All right, so now that's set up. Let's look at the front end code before we look at it again, I guess. So right in the front end, there's a lot of code that you'll write that doesn't necessarily pertain to the smart contract. It's mostly the UI and interacting with the user. But when it really comes down to it, there's actually a set of patterns that you can actually just follow to talk with the smart contract. And we'll be going through these patterns. So the first thing we always need to do is we need to get a program instance. And this program instance is basically our smart contract, how we communicate to the contract we deploy on the network. So the first thing we do is we need to get our network, which in this instance is always our localhost. So that's 127.0.0.1 and at port 8899. And then once we're on network, we can create a connection. And then with the connection, we can create a provider or a specific anchor provider. And this is just information that we talk to it. So some of that information is just what is our connection, like what network are we on, our anchor wallets. I'll show you how to get this later, and then some other configuration files. We don't need to worry too much about this. And then once we have a provider, we can create our program. All of this is provided by the anchor library. And for our new program, we just give it the IDL, which is the IDL.json we recently got. We give it the address of our smart contract on our network, which is also stored in the IDL. And then we just give it the provider, so we have all the context information. And with all that, we have our program, and now we can interact with our smart contract. More on that later. But now we get to the crux of this video. How do we actually interact with our PDA on the front end? So there's actually two things we need to do. First, we need to get the PDA or the address, the public key of our PDA. And we can do that by essentially just executing this command. And we'll see what it returns later. And these are all anchor libraries, but we call web3.publickey.findProgramAddress. And then this takes in two parameters. The first parameter is the seed that we're using. And so remember from our previous video, the seed was a string that we called escrow. We give it the from public key, which is our anchor wallet, and the to key. And then we're looking for the ID of the program that the public key belongs to. Remember, these PDAs are unique per smart contract. So we can have the same PDA for different contracts, and they all represent different things. So that's how we get the PDA. But how do we actually get the account information on it? Because remember, we have this escrow account that is stored on this address. And to do that, we run this part of the code. We use our program. We access the account that our smart contract created, which in this instance is only one thing. That's the escrow account. So of all the escrow account types, return to me the account that has this address, which is our PDA that we just found. And we execute this code, and that will give us the account information, and then we can literally do anything we want. So that essentially is how you get PDA on the front end. Now, how do we actually send the transaction? And this is one of the nice things, if you haven't noticed already, with working with Anchor, we don't need to actually provide all these helper functions to call the functions that we defined on the program. For example, in our case, we called our program create escrow. So if we want to send that transaction, we just call program. Remember, program.methods.create escrow, which is the name of the function that we defined. For those who watched the previous video, you would know that create escrow takes in one parameter, which is the amount of money we want to put up in the escrow account. Of course, in this instance, we're just setting a byte. Of course, in this instance, we're just setting a integer, and then we're even hard coding it. And so that's what this new BN is. BN is big number, I think, or byte number. Essentially, it just converts 30 into its byte form, because we need to convert everything to be bytes so we can send it across the network. Anyways, so then we need to find the accounts, and our account information, if you recall, is exactly the same from the context that we described in our smart contract. As you see, we define our escrow, we define our from, our to, and our system. And then once we have all that set up and we're ready to send the transaction, we just call the .rpc function. And that should do it. So let's take a quick look at our code. All right, so this project is actually pretty straightforward. I'll just show us the end result right now. Yarn dev. All right, okay, I have problems there, but what's this? Oh, demo PDA frontend. Okay, PDA get. Right, we just do npm run dev to start our project. And you see it's gonna be on localhost port 3000. Okay, so this is what the project looks like. First thing you'll notice is that it's asking for my Phantom wallet. This is because of the wallet adapter, but very basic website. What we have implemented is we use Phantom Wallet's UI components. So this button will allow us to change our wallet, disconnect, or just copy our address. We have another button that will disconnect us, and then we're going to have a button called create transaction, which will actually send the transaction to our smart contract. So let's go to the code. We don't actually have much, so this should be pretty straightforward to go over. All right, so in this project, and in future videos, we'll kind of learn how Next.js organizes everything. But in this project, we're just going to focus on the index.tsx, which is located in the pages over here. So inside our pages, we have our index.tsx. And for those unfamiliar with .tsx, these are essentially React components made in TypeScript. If you're not familiar with React, unfortunately, this video is not going to teach you about it. I think I made a past video in the working with Phantom.js that I did a quick overview of React, but so do visit that. But if you do want a more comprehensive video, do leave a comment below and I'll consider making one. All right, so let's look at this code. So we have a lot of imports, so we don't need to worry too much about that. One thing I will add is that for this project Serum anchor, I actually had to add it to our dependencies right here, and then do a yarn install. Very basic stuff if you've worked with any JavaScript app before. So let's just quickly get a lay of the land. So we have this home component, and it returns the next page. But home is essentially what we're exporting out. So this whole thing is the React component. So looking at the React component, let's just ignore this for now, and let's just ignore this whole async function, and just go straight to the return type. So as you see, we are returning essentially HTML. And so the HTML is pretty basic. We just have our container, we have our main, we have our h1, that's just text. And over here, this is the part that we kind of care about. As you can, these are the wallet buttons that we defined that allows us to talk to Phantom. So this is the multi-wallet button. And the second button is the wallet disconnect button. We just imported from the Solana wallet adapter React UI. This is included in the wallet adapter project. I didn't need to do anything. You just import and use it, and that's really it. So the part that's actually more custom for us is when we look at this button, this create transaction button. And all it does is when you click on it, you call the send transaction, which I define right here. So let's actually start diving into the code, which should be very familiar now because we took a sneak preview on the slides. But before we do that, let's take a quick look at line 14, or where we created this Anchor wallet. So what is Anchor wallet? Anchor wallet is just something we received from, well, it's an Anchor wallet object that we received from calling this use Anchor wallet hook. So I won't get into the React specifics on hooks, but hooks are global objects essentially that are we set. And actually, if we want to go see where it's set, we can go to this underscore app.tsx, and you can see that there's a lot of these providers that we define over here, and these providers over here, and there's a lot of other setup work right here, but these providers essentially create these parameters that we can access anywhere inside a React component. So we'll talk about this in overall video, but just focusing on the front end, it's all provided for us. Close this. So essentially what this does is if someone has set up a wallet, which is handled by these buttons, if someone has connected the wallet to this program, give me the instance of that wallet. So with that knowledge, we go back to our send transaction. And inside the send transaction, the first thing we do is if the Anchor wallet is undefined, i.e. we're not connected to anything, just return and terminate this whole entire function. Otherwise, let's just set up our program. Honestly, this could probably have been set outside the function, but whatever. We go through everything that we've talked about already, so I won't go through this again. This. And one thing I will say is we should always wrap all of our code to get PDAs or send transactions inside a try function, because all these are network requests and there could be a lot of problems like the request to the smart contract outright just failed, or maybe our internet is just dead. Inside our code, two key, there's a lot of ways we can define it. I just hard coded one of my extra phantom wallets I created. It's really easy to create wallets if you haven't tried before. But in most dApps, you probably have to actually specify the wallet on the front end, and then we'll just use that value. In this case, we're just hard coding it. Anyways, so that's our two key. And we're going to create our escrow PDA, and that address is generated from the bytes of our three parameters, which is the string, the public key, and the to key, or the from key and the to key. And remember, they have to be in byte formats. Also, another thing to know is that we always have to use await because these are all network requests. If we don't use await, all of our code just execute and we won't even get anything. And for those curious, what this is we're doing deconstructing, because if you look at find program address definition, you see that it returns a promise, and that's why we use await, because we open the promise. And what we get back from there is a public key and a number. And if we look back in our code, over here, we deconstruct and we just take the public key, the type that was mentioned in this tooltip. Now we have the public key. We can start saying the transaction. This is exactly what we saw in the slide. Our escrow is our public key for our escrow PDA. Our from is our Anchor wallet public key, the wallet that we connected to the dApp that we just created. To key is hard coded. And our system program is just a hard coded value that we import from our Anchor project. All right, so I printed out the console of our transaction, but it's not needed. And then finally, just to validate that everything we've done was correct, we just need to use our program that we defined that talks to our smart contract and call the account types that we've generated. And one of those types would be escrow account. And we just call fetch to say, hey, give me all the escrow account. Give me the escrow account data for this public address, which I promise exists. And I just printed it. And that's really it. Right, and so that is all. As you can see, I've already started the project. So let's go back to the slide for a quick final step. So before we actually practicing your code, just one of the localhost. So we need to ensure whatever wallet we use has some SOL on it because we still need to pay transaction fee. And we just do that by calling Solana airdrop 3 sols and your public key. So I'll just go through a quick example. So I open my Phantom wallet. As you see, I already have something here, so let's just go to another address. I'm creating a lot, as you can see. Go to wallet 5. I see there's no souls here, and I'm on localhost, but that doesn't really matter. So I'll just click to copy, and let's go back to my the smart contract project where we start our Solana test validator, because we need our localhost validator. And we'll just do Solana airdrop 3, and I'll just paste the public key that we just generated. There you go. Now, if we just refresh this, you'll see that we have 3 SOL tokens. And so now that I have 3, hit F12 to show up our console. I just press create transaction, get rid of these debug points or breakpoints. We don't really need them. And then once we are ready to send a transaction, probably from this right here, I went away. Phantom Wallet will ask us if we approve the transaction or not. There's no balance change found. I wonder if it's because I used this already in a previous example. Oh, okay, I know the problem. Okay, it's not that it wasn't working. It's because I changed my wallet, but I didn't change my instance over here. There's some code we could probably write to actually change that, but we're not doing that here. So see, this wallet that I'm currently connected to is BMX3, and the one we just changed to is 2JR. So it's not saying we don't have the permission to make 2JR because we're not 2JR, we're B3. Okay, now we refresh and we try again. It's not that. Try again. There we go. So, now our phantom wallet is estimating that we're going to spend 0.00015 SOL for rent on the Solana network for our PDA. Just hit approve. And then if we look at the escrow account information that we get back from our PDA, we see that we have a from public address. I'm not going to decode it. There are 2 public addresses, also not going to decode it, but I assure you those are the ones that we use to store. And if we look at the amount field right here, I'll probably bigger. And as you see, if we look at the value, which is the words, it's also in a byte format, but since our value we use is so small, we can easily tell that the value that we store is 30, which is what we set if you look at our code right here, set a amount of 30 in byte format. And that's it. Hopefully that gets you a start to understand how to talk to PDAs on the front end. If you found this video helpful, please do me a huge favor and like. And if you haven't subscribed, please do that too. Otherwise, stay tuned for the next video where I'll basically create a generic Next.js project and kind of go through some of the key concepts of Next.js so that you can build your own app using React and all the latest technology. And I'm on a roll right now, so we might actually get that maybe within next week. So with that being said, hope you all have a nice day.